Welcome students. We are going to discuss chemistry ATP paper, which is paper 6 0620 62 for Feb March 2022. The first question is about calcium carbonate reacting with dilute hydrochloric acid. In part A, we are asked state what happens to the readings on the balance as the reaction takes place. The reaction is taking place in this conical flask where calcium carbonate is there along with dilute hydrochloric acid. The conical flask is closed by cotton wool. As it is porous and gas can escape, carbon dioxide is formed during this process because it is a carbonate and it is an acid. You know that whenever carbonate is reacted with an acid, carbon dioxide would be formed. As carbon dioxide is liberating during this process, the mass of the mixture decreases, and you would notice that a decrease in mass would be displayed on the balance. So the reading on the balance decreases. As you know that this is because of the carbon dioxide being
Enroll now
liberated.
at
There is a piece of cotton wool in the neck of the flask.
www.cambridgeclassroom.com and
Suggest why
unlock your
a
full
bung
potential.
is not used in the neck. I hope you remember that a bung is basically a stopper that is used for test tubes and boiling tubes. The basic purpose is to close test tubes and boiling tubes to prevent spillage or evaporation of the substances. Sealing test tubes during reactions, preventing contamination or evaporation of substance, mostly gases. Different sorts of bungs available. For example, this one is a bung that's not having any hole in it. This one is having one, while this bung has two holes in it. So they are used for different purposes. Mostly this stopper or a bung is used that don't has any hole in it. So basically it would prevent evaporation. While as we discussed earlier, carbon dioxide is being escaped from here. That won't be possible using bung. If you use a bung, carbon dioxide can't escape. The second part is about suggest why cotton wool is placed in the neck rather than leaving the flask open. So that here an acid was used. It's a strong acid, and when a strong acid reacts, there are chances that the splash of the acid would be observed, and we don't want that. So basically, cotton wool would prevent acid splash, state which reactant is in excess. If you read the last line of the statement, when the reaction stopped, there was still small piece of calcium carbonate in the flask. So this is the reactant that is left unreacted. So basically, this is in excess. It is calcium carbonate. You can even write the name instead of writing the formula. Describe how crystals of calcium chloride can be obtained from mixture left in the flask after reaction has stopped. I hope you remember that we used HCl and it was reacted with calcium carbonate producing calcium chloride. This calcium reacted with this chloride forming calcium chloride. From here carbon dioxide was given off and the oxygen left here combined with the hydrogen of the acid to form water. You remember that only SLM chlorides are insoluble. Silver, lead, mercury. These are insoluble substances, while calcium chloride is a soluble substance. So basically this is dissolved in water and we need to separate that. But before that, this calcium carbonate need to be separated because it was in excess. To separate that, we need to filter it out first. We'll be using a filter funnel for this process. We would pour liquid into the container. Using this filter funnel, we can separate the unreacted calcium carbonate by filter funnel. So first thing is to filter the excess calcium carbonate. After filtration, we would be having calcium chloride as a filtrate. That filtrate would be placed in the china dish and it would be heated. Heat filtrate in evaporating dish or china dish as we want the crystals. So we need to heat the filtrate till crystallization point. Remember that we first filter the mixture into the evaporating dish using the filter funnel. The residue would be left here. In this case, the residue would be calcium carbonate that was unreacted, and later on this filtrate that contains crystals of calcium chloride is transferred to the evaporating dish and we would heat it till the crystallization point. This is the evaporating dish that contains the filtrate in it. This is a concentrated solution of calcium chloride that is being crystallized. At the crystallization point, the crystals start forming and we can filter it out later. At crystallization point, we would stop heating. We can even remove the excess water if present. If there is water present, then filter the crystals. And finally, you would have crystals. You need to dry them between the layers of filter paper or in an oven or even in the sun. Before filtering the water, we need to decrease the temperature. So let it cool. Then finally filter out the crystals and dry them between the layers of filter paper. This question is about temperature changes, where our student inspected the temperature change. We are given different readings where we need to write down their temperatures. Let's start from experiment 1. Look at this reading. It is above 20. It is 21 actually, but whatever you are writing the temperature, you need to write as 21.0 instead of just writing 21. This temperature is above 25 Celsius, but less than that of 26, as it is between them, so it would be 25.5 Celsius. This is exactly 21 Celsius, so we can write 21.0 here. This is 25, 26, and 27. It is above 27, so it is 27.5. It is between 27 and 28, so it is 27.5. This one again is 21.0, so we would be writing 21.0 Celsius here. This is the easiest one, as a clear line is there. It is 30 Celsius actually. So we would be writing 30.0. This temperature is between 21 and 22. It is greater than 21 and less than 22, so it is 21.5. 30, 31, 32. It is more than 32, but less than that of 33, so it is 32.5. This temperature is again above 21, but below 22, so it is 21.5 Celsius. This thermometer shows the exact temperature as 34 Celsius. So we would write 34.0 here. This temperature again above 21 Celsius but below 22, so it is 21.5 Celsius. It is below 40 but more than that of 39 Celsius, so it is 39.5 Celsius. We would be writing 39.5. Now we need to calculate the temperature changes. At the right side, there is final temperature that is written after 30 seconds. So this is basically final temperature, while at the left side, initial temperature is given. To calculate the temperature change, we need to subtract initial temperatures from final temperatures. So the first one would be 25.5 minus 21 equals to 4.5.
Enroll now at www.cambridgeclassroom.com
So first temperature change
and
is
unlock your
4.5
full
Celsius.
potential.
In the second one, it is 27.5 minus 21 equals 6.5. So the second temperature change is 6.5. For the third one, the final temperature is 30.0 minus 21.0 equals 9 Celsius. Next final temperature is 32.5 Celsius and the initial temperature is 21.5. Subtracting 21.5 from 32.5 results in 11. Next final temperature is 34 Celsius while initial is 21.5. Subtracting 21.5 from 34 results in 12.5. And the last one is 39.5 minus 21.5 equals 18. So we would be writing 18 here. Now we need to draw these points over the given graph and then we will try to draw a straight line through these points. At the left hand side we will be taking temperature changes while at the base the mass of lithium chloride would be there. After that we are given a question to calculate the temperature change for 3.2 gram of anhydrous lithium chloride. Using a scale, draw the line from 3.2 and now extend it to the left side to find out the temperature. Now find the temperature from there and you would see that it is 14 Celsius. That would be the answer for the first part of the question. Then in the next part we need to estimate the temperature change if experiment 6 is repeated using 60 cubic centimeter of water instead of 30 cubic centimeter of water, and we also need to give a reason for the answer. When we used 30 cubic centimeter of water, the temperature change was 18. As we have doubled the water, the amount of the temperature would be halved. As increasing the water would decrease the temperature. And we have actually doubled the water. So the temperature would reduce to half. So we can write that double the volume, half the temperature. In the next part, we are asked to suggest two changes that would be made to the apparatus to improve the accuracy of the results. For each change, we need to give a reason or explanation as well. So let's read the question once again. In experiment 1, we can see that the student has used measuring cylinder to measure 30 cubic centimeter of distilled water. As we are asked to improve the accuracy, we can use burette instead of the measuring cylinder because burette is more accurate than that of measuring cylinder. I hope you remember that measuring cylinder can also be used to precisely measure the liquid, but be sure that whenever we require accurate, we use burette rather than using the measuring cylinder because burette is more accurate, more precise than
Enroll
that of
now
the
at
measuring cylinder. So it can be suggested
www.cambridgeclassroom.com
here
and
to
unlock
use
your full potential.
burette for measuring the volume of the liquid instead of measuring cylinder because burette is more accurate than that of measuring cylinder. We need to mention another change that could be made here. Look at the detail of experiment 1 again and see that the student is actually trying to calculate the temperature changes while during that some of the heat may be lost to the surrounding, so student won't be able to calculate precisely. If students use a polystyrene cup, the heat loss would be reduced. Question number 3 is about solution A and solid B, which were analyzed. Solution A was aqueous copper to bromide. Solution A was divided into three approximately equal portions in three different test tubes. The end of a piece of wire was dipped into the first portion of a solution A. The end of the wire was then placed at the edge of a roaring Bunsen burner. So basically, this is a flame test, and we require to give our observation there. Flame test is about metals, and say that there is a copper metal. Now look at the data sheet given along with the paper. As there were copper ions available, the flame color of copper is blue-green. So right, blue-green here. To the second portion of solution A, aqueous ammonia was added dropwise until in excess. So basically, this is test for copper ions. Look at the data sheet. Copper ions form light blue precipitate when few drops of ammonia are added. They are soluble in excess, giving a dark blue solution. So this is the data available in the data sheet. We'll be copying here. Blue precipitates are formed, which are soluble in excess, giving a dark blue solution. Initially, it is light blue precipitate when few drops of ammonia were added. Upon adding excess ammonia, the precipitate dissolves, forming a deep blue solution. That confirms the presence of copper 2 ions in the given salt sample. The third portion of solution A, about 1 cm depth of dilute nitric acid, followed by a few drops of silver nitrate were added. So basically, this is a test for halide ion. Look at the name provided in the question. It is copper to bromide, and bromine is a halide. So basically, the test is about bromide ions. Look at the data sheet given along with the question paper. Say that bromide ions would have cream precipitate. The first portion of solution B was tested using universal indicator. The universal indicator paper turned blue. We know that bases are alkalis can turn red was blue. So basically, the observation is about having an alkali here. To the second portion of solution B, aqueous sodium hydroxide was added dropwise. A white precipitate is formed, which remained when excess aqueous sodium hydroxide was added. So basically, a white precipitate is observed, which remain insoluble. Look at the data sheet, and here the test is confirming calcium ions, as calcium ions would form white precipitates which are insoluble in excess. Test 2 confirms the presence of calcium 2 positive ions. When 5 drops of sodium hydroxide are added in salts containing calcium ions, white precipitate is formed that remain insoluble in excess, while in ammonia, no precipitates are given up. To the third portion of the solution, aqueous ammonia was added dropwise and then excess. The solution remained colorless. It means that basically there is no reaction. If you look at the data sheet, you would find that no precipitates are found if calcium ions are present. So basically, this test is confirming the presence of calcium 2 positive ions. D part asking to write pH of a solution B. As we identified that it is an alkali and it would have pH 8 to 14. As it is an alkali of group 2, so we can write 11, 12 or even 13 for it. Identify the solid B. As we identify that this is compound of calcium, and in the test 1, it is confirmed that this is an alkali. And alkali are the substances mostly containing hydroxide ions in them. So the solid would be calcium hydroxide. In question number 4, it is mentioned that fizzy drinks contain carbon dioxide dissolved in liquid. The carbon dioxide gas can be removed from fizzy drinks by heating. Plan an investigation to find the volume of carbon dioxide gas in 1 cubic decimeter of fizzy drink. Include in your answer how you will calculate the volume of carbon dioxide gas dissolved in 1 cubic decimeter of a fizzy drink. You are provided with a small sample, less than 1 cubic decimeter of a fizzy drink, and common laboratory apparatus. So basically, this question is about collecting a gas and then measuring it. Remember that we studied earlier that we can place the reaction mixture in conical flask and attach a gas range to the conical flask using a bung and heat the reaction mixture. The gas being produced would be collected in the gas range that can be measured. Using that data, we can identify the amount of gas produced from the sample of reaction mixture. So we would write that measure the volume of the sample with burette. Pour the sample in the conical flask. Attach a gas range with conical flask using a bung. Here the conical flask until no more gas is produced. Got volume of the gas from gas range and divided by 1000 to convert it to cubic decimeter. As the sample was given was less than that of 1 cubic decimeter, so we need to convert it to 1 cubic decimeter. Calculate the volume of gas in 1 cubic decimeter by the following formula. Volume of a gas in 1 cubic decimeter equals to volume of a gas collected divided by volume used.
Attention all IGCSE Chemistry Year 622 and O-Level Chemistry 5070 students. Are you feeling overwhelmed by the thought of tackling the upcoming chemistry paper? Are you craving that feeling of confidence and success as you walk out of the exam hall? Fear not, because we have the solution to all your exam worries. Introducing our IGCSE Chemistry 0620 and O-Level Chemistry 5070 crash course, the ultimate guide to conquering your exams with flying colours. Imagine the joy and pride of achieving the grades you've always dreamed of. Picture yourself opening that envelope to find the results you've worked so hard for, knowing that all your effort has paid off. Our crash course isn't just any ordinary study program. It's a game changer. With our expert tutor, the chemistry guru, Professor Faisal Janjowa, and comprehensive curriculum, you'll be equipped with all the knowledge and skills you need to ace your exams. But wait, there's more! Enroll today and get an exclusive 10% discount with code CHEM10OFF. Don't miss out on this limited time offer. Don't wait until it's too late. Enroll now in our IGCSE Chemistry 0620 and O-Level Chemistry 5070 crash course and take the first step towards exam success. With our proven track record and dedication to your academic excellence, there's no limit to what you can achieve. Join us today and let's make your exam dreams a reality. Enroll now at www.cambridgeclassroom.com and unlock your full potential.